everyone. This lesson for Algebra 1 is going to focus on properties of power, so working with exponents. And so just in general terms, I want to emphasize that exponents kind of behave differently than normal numbers do. And I'm hoping to convince you today of why that is, but that's why this is its own lesson, is that when you're working with exponents, they kind of follow their own rules. So, for example, if I hand you something like x cubed, which is a power in itself, and then I tell you to square that, let's keep in mind that what that's really saying is x to the third, which is x times x times x, times another x times x times x. Okay, so here's an x cubed times another x cubed. Notice that altogether what that leads you to is x to the sixth power. Okay, I ended up with 6 x's there. So when we look at those exponents, the x cubed and the x squared there, what did we ultimately end up doing with these powers? Well, when you raised a power to a power, we end up multiplying the exponents together. So in this first example here where I have n cubed to the power of 7, I mean, you certainly could write it out this way. And I do think this is helpful to have. Because even if you don't write it out this way, you could at least kind of visualize it. You could say, all right, n to the third would be n times n times n. If I had that 7 times, how many n's would I have altogether? So this would be n to the 21st power. So now let's look at this next example, because I really want to emphasize something here, and you're going to hear me emphasize it in just about all the examples we do. All these properties we're talking about today, the thing that we're supposed to be learning is how do we work with exponents? So how do we work with like this number and this number? But remember that when you have coefficients, which is like this 5 sitting in front here, that's just a normal number that follows normal number rules. So when I take something like this and square it, first of all, that square is getting applied to each one of these things individually. So I'm going to square the 5, I'm going to square the x cubed, square the y to the 5th, and square the z. It's not quite the distributive property, but you could kind of think of it that way. But when I work with the 5, I am no longer multiplying like I was up here, because this is a normal number. It is not an exponent. When I'm working with the 5, I am just doing 5 to the power of 2, like I normally would. Okay, this is an exponent, so 5 to the power of 2 is 25. And then when I go to work with all these powers, now I'm going to use this rule up here. So this would become x to the 6th. The y would become y to the 10th. And the z, which right now you could think of as having a 1 on it, 1 times 2 would give me 2, so that would leave me with a z squared. Okay, next up, let's talk about multiplying two powers together. So something like x cubed times x to the 4th. If we sort of write that out the long way, here's x cubed, x times x times x, okay, times x to the 4th. And so if you count up all of those x's, altogether you end up with x to the power of 7. So again, let's look at our exponents here and look at our result. And what ended up happening here? Well, what ended up happening is we added these exponents together. So when you multiply powers, we add the exponents. So looking at m cubed times m to the 8th, that's going to leave me with m to the 11th. And even if you didn't write it out, you could think of it as, okay, this would be 3 m's, this would be 8 m's, so altogether I would end up with 11 m's. When I go down here to something like this, and I'm going to emphasize the same thing again, the 5 and the 3 are normal numbers, and they are going to follow normal number rules. So if this is multiplication in between here, which is what it is when two parentheses are next to each other, I'm going to combine the 5 and the 3 by multiplying them. And then this rule here kicks in for all of these powers. So I have g to the 3rd times g to the 1st, which gives me g to the 4th. And then h to the 5th times h squared is going to give me h to the 7th. So once again, I'm really thinking of all of these individually and combining the pieces that can be combined. Okay, let's keep going. So we just did multiplication, so now let's talk about dividing, and hopefully, based on the rule for multiplication, I would hope that you have a guess about what the rule for division is going to look like, but just like usual, let's write this out. So x to the 5th would look like this, and x squared would look like this. And if you've got x's on top and bottom, they can cancel each other out. And so if you look at what you have left here, you have 3 x's multiplied together. So looking back at my original problem, what happened here is we ended up subtracting. So when you're dividing powers, we're going to subtract the exponents. Same deal. Let's do 2 examples here. So x to the 9th over x to the 5th, 9 minus 5 gives me 4, so I have x to the 4th power. With something like this, I find it helpful, and I know I've been doing this in just about all of them, but especially helpful with division to kind of line these things up. Once again, the 16 and the 8 are normal numbers, so this is just saying 16 divided by 8, which is 2. A to the 5th over a squared, 5 minus 2 leaves me with 3. 9 minus 3 leaves me with 6, and 4 minus 1 leaves me with 3. And that's what that one would look like. Okay, so let's talk about zero exponents. And I'm gonna kind of show you where the rule for zero exponents come from, but they're actually really easy to do. So if I gave you x to the 4th over x to the 4th, if we follow our division rule that we used just a second ago, I would do 4 minus 4, and I would call this thing x to the power of 0. But if I think about this algebraically, or if I think about this in terms of all the other fraction stuff you've ever learned, anytime the top and the bottom of a fraction are exactly the same, we know that that's going to equal just a 1. So just for reference, this is the same thing as like 3 over 3 or x over x. Okay, all of those things equal 1. Anything over itself equals 1. And so what this tells us is that anything to the power of 0 is always equal to 1. That's a whole number 1. That's not a power of 1. That is just the number 1. Okay, which means working with powers of 0, a lot of the times it's going to be almost like it cancels out. Now, be careful with something like this, though. That power of 0 only applies to the b, the way this is written. So this is really saying like -4 times 1, which is just -4. So you can think of that 0 as canceling out the b, but it doesn't do anything to the -4. However, with this one, I've got this whole mess inside of here with a power of 0 on the outside. That means all of these things are going to get raised to the power of 0, which means everything is just going to become a 1. And so my final answer there would just be 1. All right, moving right along, I think we've got negative exponents next. This is the first thing that may start to feel a little bit tricky. Okay, I've gone kind of quickly through these other things, but negative exponents, if you're not careful, can mess you up a little bit. So let's talk about where negative exponents come from first. So if I have, let's say, x to the 3rd over x to, I guess I didn't mean to draw that long, x to the 3rd over x to the 5th, let's say. If I'm following my rules that we talked about before, this division rule. When I divide, I subtract exponents. Okay, so 3 minus 5, I would call this thing x to the power of -2. Okay? But let's think about what's really happening here. This is the same thing as, here's x times x times x. Here's x to the 5th. And I'm going to cross them out up and down, just like I did before. So I'm left with 2 x's, but notice where those 2 x's are located. Okay, those 2 x's are located on the bottom of a fraction, which I would write as 1 over x squared. Okay, so what happens is a negative exponent makes your fraction flip over. It takes whatever thing it is that's being raised to that power, and it makes it a reciprocal. So negative exponents mean to take the reciprocal. Oops. Big note to make for yourself here. Negative exponents do not make numbers negative. Okay? A negative exponent is not an actual negative number. It doesn't turn your answer negative. Your answers won't have a negative sign in them unless they started with a negative sign in them. There's no exponent that's going to turn a number negative. So let's talk about that when I look at this first example. When I see 4 to the power of negative 3, that does not mean your answer is negative 64. That's the most common wrong answer that I see, because 4 to the third is 64, and so then people just want to make it negative. But what this is actually saying is so this right now is like over 1. It's saying take that fraction and flip it. So it would be like 1 over 4 to the third power. Okay? And 4 to the third power is 64, so I would write this as 1 over 64. So it's flipped over like a fraction. It is not negative. So when I look at this next one, first of all, there's nothing I can combine here because we are definitely going to get into some like this where we have to do some combining first. But everything is simplified as far as it can go. We just need to rearrange some things. I want to emphasize that there are 3 separate pieces here, okay, that I'm working with. The 2 is fine where it's at. The 2 is happy where it's at. The y to the 5th is on the bottom, but it's got a positive exponent there, which means it's happy where it's at. The problem is this x to the negative 2. I always make the analogy that negative 2 is like saying that the x is unhappy where it's at. Okay? That negative exponent is going to take that x and move it to the bottom of the fraction. That's what negative exponents do, is they move things to the opposite part of the fraction. By the way, if this y, if the power on y had been negative here on the bottom of the fraction, I would have moved it up to the top. So the way I would write my final answer here is, really I'm just taking that x squared and moving it downstairs with the y. The 2 stays where it's at. The y to the 5th stays where it's at. I'm just going to put the x squared downstairs. Okay, so now let's look at this next one. And you're going to notice that in this next one, I'm going to write some pieces out first and then do all my rearranging at the end. Decide what needs to go on the top and what needs to go on the bottom at the end. So the first thing I'm doing is 4 to the power of negative 2. Okay, and we'll deal with what that actually equals in just a second. Then I'm going to do b to the third to the negative 2. So that's a power to a power, which means I'm multiplying. So that's going to be b to the negative 6 power. And then look at what happens here. Negative 4 times negative 2 becomes positive 8. And that's why I say don't worry about rearranging things until the end, because sometimes the negatives cancel themselves out. So if you dove right into this and said, hey, wait a minute, that's a negative exponent, it needs to go on the bottom of a fraction, this negative exponent would have brought it right back up to where it was before. So looking at these 3 pieces, this one and this one are going to need to move downstairs. They're going to need to move underneath the c to the 8th. c to the 8th is happy up on top of the fraction here. So I'm going to leave c to the 8th here because it's positive. On the bottom, really what I'm doing is 4 squared, which is 16. And the negative is what made it go on the bottom of the fraction. And then this b to the 6 is going to go on the bottom as well. And notice that once I move things to the bottom, the negative goes away. The purpose of the negative was to get you to move it to the bottom of the fraction. Once it's there, you can turn it back to being positive. Okay. Let's see. What do we have left? I think just mixed practice. Yeah. So I definitely want to cover those mixed practice, but I think I'm going to do that in a separate video so that people can access just those mixed practice examples on their own if they would like to. So this really covered most of the notes for the lesson. Please come back and watch those mixed practice examples. You may want to try a little bit of your homework first before you watch those examples. That's fine with me. But you can head off and, like I said, either dive into the second part of this video or start your homework, but just make sure that you do come back to the second part of the video at some point. Okay, have a great day.